All right, in the last chapter, we talked about operations with integers, and those were positive and negative whole numbers. So now we're going to expand our number set a little bit. We're going to talk about fractions and decimals today, specifically writing fractions as decimals and the types of decimal numbers we're going to be encountering here in pre-algebra. So the two types of decimals that we're going to have, or the two types of decimals that could exist, are repeating decimals and terminating decimals. And a repeating decimal is a decimal value that has an unending repeating pattern of digits, and a terminating decimal is basically the opposite of that. That's a decimal value that does not have a repeating pattern of digits. So in the boxes below, I've got examples of both repeating decimals and terminating decimals. So on the left, you can see examples of repeating decimals like 0.33333333, and those dots mean that those threes go on forever, infinitely. They never end. Likewise, we've got 0.166666 and so on. There, the 1 does not repeat, but the second digit, the 6, does keep repeating over and over again. And then we've got 0.18181818. Here, 2 digits repeat over and over again. And again, repeating decimals can be positive, they can be negative, they can be greater than 1, they can be less than -1 as well. But I just showed examples here of numbers less than 1 or greater than -1. On the right-hand side, we've got terminating decimals. These are the decimals we're probably more familiar with. Terminate means to end or to stop, and so a terminating decimal ends or stops at some point after a finite number of digits. So obviously 0.5, 1/2, that is a terminating decimal. 0.98, 0.7639. Those are all terminating decimals, or decimals that eventually come to an end. And then one I want to point out here, just so we don't get confused, is this one right here, 0.222. Now, some people call that a repeating decimal because the 2 repeats over and over again, but it does not go on forever, so that is not considered a repeating decimal. So be careful with those types of decimal numbers. Even though the digit repeats, it doesn't repeat unendingly or forever. So 2 types of decimals we're going to talk about: repeating decimals and terminating decimals. So how do we write fractions as decimal? A fraction is a ratio of 2 numbers, so it can be thought of as division. Basically, a fraction represents kind of a division problem. So in the green box, to write a fraction as its decimal equivalent, we simply divide the numerator by the denominator, or top divided by bottom. And we can do this longhand with long division, or simply do it on a calculator. I'm just going to do a couple examples here of longhand division, just to remind you, or maybe show you for the first time if you haven't seen longhand division, how to do this. So if we want to write 7/8 as its decimal value, we can think of this as 7 divided by 8, numerator divided by denominator. So to do that, we're just going to I'm going to extend my box here a little bit. And 8 does not go into 7. 8 goes into 7 0 times. So it's going to be less than 1 whole time that 8 goes into 7. So our decimal is going to be less than 1, which makes sense because 7/8 does represent a value that's less than 1. So we're going to think, well, how many 8s would go into 7.0? There's going to be less than 1 of those. So thinking 8 into 70 is kind of what I'm thinking about. And the most it would go would be 8 times, or 8/10 of a time it would go in. So 8 times 8 is 64. And then I would find out what I have left over, and that's 6. So we still have to keep dividing if I get a remainder of something other than 0. So now I'm going to drop another 0 here. 8 goes into 60 7 times. 7 times 8 is 56. And then find my remainder, which is 4. I still have a remainder other than 0, so I got to keep dividing. So I'm going to drop another place value here. 40. 8 goes into 40 5 times. 5 times 8 is 40. And so I will not have a remainder. So I am done dividing. So that decimal actually terminates. Okay, it stops eventually. I don't have to keep dividing forever and ever. So 7/8 as a decimal value is 0.875, or 875 thousandths. Let's look at the next one. 4/5 as a decimal. We can think of that as 4 divided by 5. And again, I'm just going to extend my box here. 5 is going to go into 4 less than once, so I know this is going to be 0 point something. It's going to be less than 1. So I'm thinking 5 into 40. How many times does 5 go into 40? And that goes in 8 times. And 8 times 5 is 40. And I get a remainder of 0. So that one terminated pretty quickly. So 4/5 as a decimal is 8/10 or 0.8. So that's using longhand division to turn a fraction into a decimal. Again, we can use our calculator to just do the top divided by bottom there as well. So how do you write a decimal that repeats? If I'm converting a fraction to a decimal, and then either whether I'm doing it with my calculator or I'm doing it longhand, and I find out that the digits repeat, I don't want to waste a lot of space repeating all those digits over and over again. There's actually a shorter notation that we're going to use that's called bar notation, and that's using a bar to write over the digit or the digits that repeat in a repeating decimal. So if you look at the table, I've got a few examples here of repeating decimals and how to use bar notation to rewrite those in a shorter, more compact way. Here we have 0.16666, and those sixes just keep repeating. So you can see that we use bar notation here to write 0.16, and the bar is just over the 6. Notice it is not over the 1 and the 6. That would mean something different. So we just put the bar over the digit that repeats, and that's bar notation. In the second one, we have 0.353535. Here we have 2 digits that repeat. So we're going to put our bar over both of those digits, the 3 and the 5, because they both repeat. That indicates that this decimal is 0.353535. The next one is a number that's greater than 1, actually 12.688888. And here again, the 8 is the only thing that repeats. So again, we write all of the digits, 1, 2.68, but only the bar goes over the 8. And then lastly, we have 5.7142857142885, and so on. And this doesn't start repeating for quite a while. It doesn't start repeating until after the 5. So we have 6 digits that repeat. So again, we write the 6 digits that repeat out, and we're going to put that bar over all 6 digits. So sometimes it takes quite a while for our digits to finally repeat, but we have to put a bar over all of them. So don't round those off. So here, let's take a look at a couple of examples of more fractions, and we're going to convert them to decimals, and we'll see what happens here when we do these longhand. Again, 5/12 is 5 divided by 12, so that's what I'm going to do here, 5 divided by 12, and again, 12 does not go into 5, so that's 0 point something. 12 goes into 54 times, and 4 times 12 is 48. And with I have a remainder of 2. I still have a remainder other than 0, so I'm going to drop another place value and keep dividing. 12 goes into 20 once. 1 times 12 is 12. And again, I have a remainder of 8, so I'm going to bring another place value down. And 12 goes into 86 times. 6 times 12 is 72. So again, I have a remainder of 8. And if I bring another digit down or another place value down, I'm going to have 80 again. So now I can see that, again, 12 is going to go into 86 times, and that's 72 with a remainder of 8. I'm just going to keep getting a remainder of 8, and this process will never end. So that's going to be repeating. So now I know that this decimal is going to repeat. So to write this as a decimal, I'm going to use bar notation. So my 5/12 is equal to 0.416, and just the 6 repeats, so that's all I'm going to put the bar over, is just the 6. And then the next one, write -2/11 as a decimal, and don't let the negative confuse you or make you think this is any more difficult. It's still the same process. I just know that my decimal is going to be negative as well, so I'm just going to ignore the negative for now. I'm going to do 2 divided by 11, and again, 11 does not go into 2. This number is going to be less than 1, so 0 point something. 11 goes into 20 once. 1 times 11 is 11. I've got a remainder of 9. I still have a remainder, so I add another digit, another place value. 11 goes into 98 times. 8 times 11 is 88, with a remainder of 2. I still have a remainder, so I bring another place value down. And again, 11 goes into 20 once. with a remainder of 9. Now we can see that we're not getting the same remainder every time, we're getting the same remainder every other time. It's a remainder of 9, a remainder of 2, a remainder of 9, a remainder of 2. So again, if we continued this process, we're going to get another 8 here, which is going to lead to another 2, which is going to lead to another remainder of 9, and so on and so forth. So this is going to repeat, but it's 2 digits that are repeating. So my fraction, negative 2/11, is going to equal negative 0.18 repeating. Both of those digits repeat, so I make sure to put the bar over both the 1 and the 8. So that's what it looks like when you do it longhand. Again, if you do it on the calculator, it'll just pop up 18181818. Now it might round that last digit on the screen to a 2. But don't think that that's actually a 2. Your calculator actually rounds the last digit. So just a summary here. Here are some common fractions and their decimal equivalents. These would be nice to have memorized. These are very frequent fractions that occur. It would also be nice to have these unit fractions here at the bottom memorized with denominators from 2 to 10. A lot of common fractions will have denominators from 2 to 10. So it's nice to know those unit fractions, because if you know a unit fraction, you can figure out any of the other fraction to decimal equivalents with those denominators. But the question I have here is, what denominators produce repeating decimals? That way it's pretty easy to recognize just from the denominator whether your decimal is going to end up being repeating or not, because if it repeats with one denominator, it will repeat with all of the numbers with that same denominator. So just running through these really quickly, any fraction with a denominator of 2 will never repeat. The 1/2 is 0.5 as a decimal. That's not repeating, so no fraction with a denominator of 2 will repeat. 1/3 is 0.3 repeating, so any fraction with a denominator of 3 is going to end up repeating unless the numerator is a multiple of 3. For example, 3/3 is not going to repeat, or 6/3 is not going to repeat, or 9/3 is not going to repeat. Every other one will repeat though. 1/4 has a value of 0.25 terminating, so no fraction with a denominator of 4 will repeat. 1/5 is 0.2 or 2/10. That is not a repeating decimal, so none of the fifths will repeat. 1/6 is 0.16 repeating, just the 6 repeats on that, 0.1666. We saw that on the other slide. So all of the sixths will repeat. 1/6, 2/6, 3/6, 4/6, and 5/6 will all repeat. 7th, this one's kind of a crazy monster here. 1/7 is actually 0.14287 repeating. That has 6 digits that repeat. So every 7th is going to have 6 digits that repeat. It's kind of a crazy fraction. If you want to see something cool about all of the 7s, you can ask me about that and I'll show you. But all of the 7s will repeat. 1/8 is 0.125. That's terminating, so all of the 8ths will terminate. 1/9 is 0.1 repeating. So all of the ninths will repeat, 1/9, 2/9, 3/9, and so on. What's easy about the ninths is whatever's in the numerator, that's what digit is going to repeat. So 1/9 is 0.1 repeating, 2/9 is 0.2 repeating, 3/9, which is 1/3, is 0.3 repeating, 4/9 would be 0.4 repeating, and so on. So ninths are kind of easy to convert to decimals as well. And then 1/10 is just 1/10, and that terminates, so all of the tenths will terminate as well. So just nice to know those unit fractions to make those conversions. Comparing fractions and decimals, sometimes we have to compare numbers that are in different forms, so we need to know how to compare them to see which one is larger or smaller. A couple of major ways to compare fractions and decimals. One would be to write the fractions, or write as fractions with the same denominator. That's a little more labor intensive. It takes a little bit more work to do. But if your fractions already have the same denominator, I would just leave them that way. That way they're easy to compare. Or if they're easy to get into the same denominator, then it's easy to compare. Otherwise, I would go with the second strategy, which is just to write them as decimals. Convert the fraction to a decimal if there is one, and then it's easy to compare decimals by comparing their place values. So let's look at these 3 examples here, and I'm going to convert these to decimals. 1/4 is 0.25. We just saw that on the last slide. And 0.2 is kind of like 0.25 to 0, so they have the same number of digits there, and 25 hundredths is greater than 20 hundredths, so that's easy to make that comparison. So 1/4 is bigger than 2/10. Next one's -5/8 and -6/9. I'm going to convert these both to their decimal values, and remember with negatives, the one that is closer to 0 is actually larger. So we have -5/8, which is -0.625. And then this ninths that I just said, that's going to be 0.6 repeating. So I'm just going to write 3 digits there out to the thousandths, so it has the same number of digits as the other number. This number on the left is actually going to be closer to 0, so it is actually greater than 0.6 repeating. So -5/8 is greater than -6/9. And then the last one, 7/8 as a decimal, is 0.875. And then 0.870, just so they both go to the thousandths place. So 875 thousandths is greater than 870 thousandths. So 7/8 is greater than 0.87. So continuing on with our discussion here of new types of numbers, fractions and decimals, how to convert our fraction to a decimal, and then how to make comparisons with them.